Hey, St. Mary grade 8s. Mr. McHenry back for another math lesson. This math lesson is going to be on Pythagorean theorem. So a right triangle, and we know it's a right triangle because it has the right angle symbol in the corner. Okay, so we need to identify that it's a right angle triangle. Has two legs that form the right angle. And the third side opposite the right angle is called the hypotenuse. And we can see that on this triangle here. We have opposite the right angle is the hypotenuse. And the hypotenuse, as we just said, is always opposite the right angle, and it's always the longest side. And then we have the two legs that form this right angle. These three sides of a right triangle form a relationship known as Pythagorean theorem. And we're going to figure out how that was discovered. So in the right triangle below, the hypotenuse has length C, and you always label the hypotenuse C. One of the legs has length A, and the other leg has length B. And it doesn't matter which leg you label as A or B. So what this guy in ancient Greece, Pythagoras, figured out, and that's why it's called Pythagorean theorem after him, is that the area of the square of the hypotenuse is equal to the sum of the areas of the squares of the legs. So this square on the hypotenuse is equal to these two squares on the legs. And he came up with an algebraic equation for that using the letters that we have put on the triangle. C squared is equal to A squared plus B squared, or as I refer to it, I just flip it around. A squared plus B squared is equal to C squared. Pythagorean theorem is true for all right triangles, and we can solve problems involving right triangles. We can find the length of any side of a right triangle. And this is important, we can find the length of any side of a right triangle when the lengths of the other two sides are known. So just some steps to find the length of a side of a right triangle. We want to always identify the hypotenuse. Again, the hypotenuse is always opposite the right angle, and label it C. We want to label the legs of the triangle A and B, and it doesn't matter which you label A and which you label B. And we want to write down Pythagorean theorem and I use it as A squared plus B squared equals C squared. We want to substitute for the known letters, and then we're going to solve for the unknown letter. So we have an example here, and we're going to solve for the unmarked side. So we have a right triangle, and the first thing that we want to do is we want to identify the hypotenuse. So I look at the right angle symbol here, and I go opposite, and I say the hypotenuse is here, and I'm going to label it C. The next thing I'm going to do is I'm going to label the legs of the triangle. So I'm going to label this leg here 10 centimeters, which is has a length of 10 centimeters. I'm going to put that equal to A, and the other leg, which has a length of 7 centimeters, I'm going to label as B. So the unmarked side before was where C is. So we're going to solve for C. So now we're going to write down Pythagorean theorem. A squared plus b squared is equal to c squared. Okay, I'm going to substitute in for the known letters. Well, I know A is equal to 10, so it's 10 squared plus, I also know B, which is 7, so 7 squared is equal to C squared. Okay, 10 squared is equal to 100 plus 7 squared is equal to 49 is equal to C squared. And this is equal to 149 is equal to C squared. Well, I don't want to know that 149 is equal to C squared. I want to know what C is equal to. So in order to find out what C is equal to, I need to take the square root of C squared on the right side. But we know this is an equation, and in order to keep the equation balanced, what you do to one side, you must do to the other. I then also need to take the square root of 149 on the left side. So I can do that here. So I'm going to take the square root of C, or I'm going to unsquare C squared. Whatever I do to one side, I must do to the other. So I'm also going to take the square root of 149. The square root of C squared is C. The square root of 149 is, and I'm going to round to 1 decimal place, is 12.2. And we put approximately with that dot. And then I can now say, therefore, the length of the unmarked side is 12.2 centimeters. Okay, let's do another example. So again, I want to solve for the unmarked side, and the unmarked side is this side right here. But before I can move forward, I need to identify the hypotenuse, which is opposite the right angle symbol. So C is equal to 12 centimeters. Now I'm going to label the legs. So I'm going to label this leg here A. So A is equal to 9 centimeters and the other leg is B. So we're going to be solving for B. So I now write Pythagorean theorem down. I substitute in for the known letters, so I know A is 9 squared plus, I don't know what B is, so that I leave that as B squared is equal to, and then I know C is equal to 12 squared. Okay, I simplify here, so 9 squared is equal to 81 plus B squared is equal to 144. Okay, so I need to isolate for B squared. So what am I going to do? Well, I'm going to get B squared by itself. In order to get B squared by itself, I need to get rid of this 81. So in order to get rid of this 81, I'm going to subtract 81 from the left side, but as we know, whatever you do to one side, you must do to the other. So I must also subtract 81 from the right side. This cancels out here, and I'm left with B squared is equal to 63. Well, I don't want to know that B squared is equal to 63. I want to know what B is equal to. So to solve for B, I need to take the square root of B squared. And whatever I do to one side, I have to do to the other. So that means I have to take the square root of 63. So I take the square root of b squared to unsquare it. And I also take the square root of 63 to keep the equation balanced. So b is equal to approximately 7.9. Okay, so therefore the unmarked side equals 7.9 centimeters. So we see there that we can solve for any side of a right triangle using Pythagorean theorem. Please check D2L for the practice questions so that you can feel comfortable with and confident with Pythagorean theorem.